Let's talk in more details about mechanical waves. Firstly, we'll talk about wave properties. When you want to define a wave in physics, firstly, you imagine that as the wave in the sea, or the wave in a cup of water, the wave in a lake. The wave in two-dimensional representation, a path that's going up and down. That path has an equilibrium position. You can imagine that as the surface of your water cup. And the wave goes up to a peak, then hits the equilibrium position and go down to a negative peak and repeats itself over and over again. What is the amplitude? It is the distance between the equilibrium or the settled surface to the highest point in that wave. So that's the amplitude here. You have an amplitude here as well. And you have an amplitude here. The author is calling the top of the wave as the crest, like the positive wave, and call it as a trough for the negative wave, but we call it positive wave and negative wave, and this is the top of the wave for the positive wave, and this is the top of the wave for the negative wave. That will make things easier. Now, what is the period in this case? The period is from the point or a starting point, the top of the first wave. So period can be measured based on your first reference. So you can say, I want to start with the top of the positive first wave. Then the period will be from the top of the first positive wave to the top of the next positive wave. And you can start as well from the point where the wave crosses with the equilibrium position. So you can say the wave start from the first cross to the next cross. Or you can go, the wave goes from here all the way to here. In this way, we are measuring period. Or you can say from here to here, that's another period. You can go from the top of the negative wave to the top of the next negative wave, and that would be a period as well. So it depends really where is your reference, where's your starting point to measure the wave, but all should be the same. There's some meanings. We can say wave front, that is moving out from the point of the origin towards the barrier. That what we call as incident wave. So when the wave is going towards a barrier, then we measure between the point of origin towards the barrier, and we call it as incident wave. Let's say we have a barrier here. So from the starting point, that's an incident wave. And when we have a series of waves linked together, that's called a wave train. There's something in waves, we call it phase. When one wave is moving exactly as the other wave, we call those two waves are in phase. Now, some people are defining the behavior of waves in terms of rays. Like, let's say you drop a rock in a water cup or in a lake, then it will create those circles or those series of waves. We can see that the rays are defined as from the center of the wave all the way to the outside of the wave in terms of rays, outer rays. So those rays are considered as velocity vectors. But again, this is a wave, this is a wave. Then you have the wave source, and you have the positive top side of the wave, and you have the negative top side of the wave as well. Another thing to mention, when your wave is hitting a hard object or a certain surface or a barrier, the wave will go back in a certain way as if there is an imaginary source. So it's like there's an imaginary circle hitting that wave. So you can see the wave will have this shape in solid line over here. It seems like there is an imaginary ball that's hitting the wave and pulling it backwards. So some authors love to say that there's an imaginary source that you can imagine that will help them in solving the behavior of the waves while they're hitting the barriers. But of course, it's an imaginary source. It's not realistic. It just helps in identifying or explaining the behavior of waves in mathematical terms.